To graph a logarithmic function, like this particular problem here, you need to rewrite into exponential form and select values for y first. So if I rewrote this, my base raised to my power is equal to my number. So this is why I need to get values for y, because it's easier for me to go 3 to the whatever in order to find x. So let's get some values. Three to the negative 3 is the same thing as 1 over 3 cubed, and that would be 1 over 27. Go ahead and you fill out this table. I will too. I just need you to see if you can get what I get. That would be 3 to the negative 2, so it would be 1/9. That would be 1/3. 3 to the 0 would be 1. 3 to the first would be 3. 3 squared is 9. And 3 to the third would be 27. The points are plotted here. And if you'll notice, my 1/27th, and we go all the way down here, it looks like it's on the y-axis, but it isn't. But it's so close. 1/27th of something is very, very small. So that would be my 1/9 down -2, my 1/3 down 1. And if you'll notice, these go by threes because my numbers start getting bigger. So this is my 1/0. There's my 3/1, my 9/2, and my 27/3. And this does continue. So there's the key. Rewrite into exponential form and select your values for y first. Now between these two, remember this is an exponential, this is a logarithmic. Notice the domain of my exponential is the same as the range of my logarithmic. The range of my exponential is the same as the domain. I do believe this starts looking like that these are inverses of one another. Remember that line that we could go through here, y equal x? And they are, sorry, I've got to turn it sideways to see if they're symmetrical to one another, and they are. We'll keep going with this. Horizontal asymptote for my exponential is y equals 0, but the logarithmic has a vertical asymptote, which is x equals 0. Passes through the point 0, 1, and if you reverse those, passes through the point 1, 0. So they are inverses of one another. Now the next part is very simple, and you will see it, I promise. You have to find the domain. Now the domain of a logarithmic, it has got to be greater than 0. That's the key right there. I don't care what the base is. The base could be 5, 30, 50, 99 for all I care. This part back here has got to be greater than 0. So you pull it out and set it greater than 0. And we've had problems like this early on. X is greater than -3. So if you put it on a number line, open dot, and it's going that way. But it wants interval notation, so it'd be -3, comma, infinity. Pull it out. So I've got 5 minus x greater than 0. Negative x greater than -5. I'm going to divide by -1, which flips my signs. Open, going that way. So interval notation. Now I could graph that. It is base 10. So let me graph it.
Good morning. How are you today?
Negative log 5 minus x. Graph. It's coming in from negative infinity And I'm going to move my window over a little bit. Let's see if it ends at 5. Boop, done. I also said it doesn't matter what the base is, so let me try another one. Negative ln 5 minus x. Come from negative infinity, and it's ending at 5. Okay, so the base doesn't matter. What does matter is that whatever you're taking the log of, whatever your number is, has got to be greater than 0. Okay, thank you.